Good morning, good afternoon, or good evening, depending on where you are in the world. And thank you for joining this workshop brought to you by AWS. My name is Cody, and welcome back to Techstrong Learning. Before we dive into today's session, I have just a couple of notes to review with everyone. First off, we are recording our session today. So we will be sending you an email with a link to access that recording on demand. You'll get that right after we conclude this live session. Now, if you'd like to get involved, there are a couple of ways to do so. Your first option is to use the chat tab on the right side of your screen. And when you find that chat section, we'd like you to let us know from where in the world you're joining today. Now, if you have specific questions, you'll find that Q&A box on the right side of your screen as well. And we'd like to have you send those questions into that Q&A tab. Of course, if they go into the chat, we'll be keeping an eye on everything. But those are two places where you can best communicate with us. Additionally, we will be selecting two of our most engaged attendees today to win a $50 Amazon gift card. So be sure to send in your chats, send in your questions, and to fill out our survey, which is attached to the handout section, but we'll touch more on that at the top of the hour. So diving into today's topic, AWS DeepRacer, get hands-on with AI. I'm joined today by Seha Krai, Senior Technical Account Manager at AWS. Also joined by Todd Bevins, Technical Account Manager at AWS. And we also have Parth Desai, Parth Desai, Solutions Architect at AWS as well. So Seha, Todd, and Parth, thank you all so much for joining us today on Techstrong Learning. I'm really excited for this next 2 hours. Seha, how would you feel about getting us started?
Hey, thanks for that introduction, Cody. Really glad to have everybody here, and let's get rolling with AWS DeepRacer. So let's talk about DeepRacer, machine learning, the power that drives DeepRacer. What exactly is DeepRacer here? It's a little 1/18 scale car. Todd, I don't know if you have one that you could hold up and kind of show everybody while this video is running here. But it's 4-wheel drive. It's powered by Intel Atom processor. Including in that is their sensors, the camera that's powered by Deep Lens here. We also have additional components with the LiDAR. Todd doesn't exactly have that one there, but you can see the skate chassis there. There's a battery, the motor, your typical RC car. There it is. But taking a closer look at that here, some of the things that power it, that's camera. There's a stereo camera setup also. Typically, we run with a single camera kit. There's also the LiDAR sensor that you can add on. But the software that's running it, it's open source, OpenVINO. It's a Ubuntu with a robot Foxy Fitzroy. And it's powered by wireless connection. So taking the next step, why it's time to upskill your machine learning. There's been a lot of buzz this past year, on Gen AI, machine learning, deep learning, things like that. So take a look at some stats here and why you are here and why you want to be here. Machine learning is critical for the future. It's estimated there'll be some 97 million jobs that are going to be created by the growth of AI. And there's a deficit right now. Even though with the number of talent going into the field, there's roughly about 480,000 of those folks that are in the field. So there's a huge deficit. This is your time to upskill your team, and get learning. So what does the AWS machine learning stack look like? It's very overwhelming, right? There's a lot of services, there's a lot of components to it, and we'll break those down into 3 main layers here. These layers each have their own components. They all have their own technical folks, developers, business users, and we'll see that here. On the very first layer, it's the foundation. This is where the frameworks are, the infrastructure, the hardware. You'll see things like TensorFlow, PyTorch. This is where your in-depth machine learning folks are going to be touching the machine learning stack. There's also the CPUs, the GPUs that run it, right? AWS Trainium, AWS Inferentia, our own silicon that are running it. We have our EC2, P4, and P5 instances. As you move up the stack, we take that undifferential heavy lifting out of there. So when we talk about machine learning services like Amazon SageMaker, those are more geared toward your traditional data scientists, some of your developers. And this is where they can write their own notebooks, some coding, but it's all a fully managed service. It removes a lot of the complexity, a lot of the configuration, a lot of the setup, just overhead that they don't need to deal with. And again, it gets them started really fast. As you continue to move up the stack, these are where your business users or developers that just need to move very quickly will use these services, right? They're all exposed by APIs somehow, some form, and it lets them use these services for machine learning quickly. For instance, Amazon Fraud Detector. You don't want to build a fraud detection program. You can just call the API, upload your own data set in there. If you have a contact center, Amazon Contact Lens for Connect is a great way to identify fraud or voice ID. As you can tell, there's a lot of services here. It's always new. There's always more being added to it. So how do you build your team skills? Well, there's a hands-on approach, which we're talking about today with AWS DeepRacer. We also have Deep Composer, which is the little MIDI keyboard. And then we also have the Deep Lens, which is actually what's powering the camera on the DeepRacer model. And then there's a lot of training certification programs that we have out there, the AWS certification, some open courses, Udacity, Coursera. We also have AWS Skill Builder. A lot of different ways to get started and a lot of ways to continue to upskill. So, a few years ago, we asked, how do we make machine learning more fun, practical, and then be able to put it into the hands of every developer? And not only developer, business use cases. We even take these to, school-age children. And literally, we brought out AWS DeepRacer, which, the little car here with the camera, the all-wheel drive battery. So in November 2018 at reInvent, we introduced this service here, and that's how we're going to dive in today. So AWS DeepRacer Evo, this is the stereo camera with the LiDAR. Today, we're going to speak about how to do the 3D racing simulator on AWS DeepRacer, where you can train a model in the virtual environment in the AWS console. And at the end, we'll talk about that later with Parth here. There's an AWS DeepRacer League where you can train your model, submit your model to the league, and bring that to reInvent in Las Vegas. If you're not going to Las Vegas for reInvent or you don't have any interest in the league, you can also set up community races, and that's what we'll have set up later today as well. You can set up races between friends, between other universities if you're a college, other companies within your company. So quick what machine learning is and a little bit what about reinforcement learning. At the core, machine learning is really taking these simple inputs and getting simple outputs, right? But then if you want to talk about more about deep learning, you're taking a lot more sensor data, a lot of more data sets, and making a complex input, putting it through a neural network, and then you're still getting a simple output. At the end of the day, that's what we want, right? Simple outputs that are humanly readable, understandable. So let's talk about some terminology that kind of gets tossed around. We hear it all the time, especially these days with Gen AI and things like that. Artificial intelligence is a broader term. This is where we build these algorithms and have them process the information that we give it to inform us of future decision, right? So you could actually do this with just basic coding, but then it's really static output. Now comes machine learning, where we teach the algorithm on how to learn without explicitly telling it how to do so. Right, so, and that's a subset of artificial intelligence. And then within machine learning, there's three main categories here. We have supervised learning, unsupervised learning, and reinforcement learning. And we're going to talk about that for a second in the next slide here. Now, supervised learning, this is where you label data. For instance, you might have a collection of pictures of dogs, and you tell the model that these are dogs. These are all pictures of cats. These are all pictures of something here. And it learns from that. Unsupervised learning, for example, has no labels, but it'll cluster data that's like data. So it might be random pictures of the landscape, an environment, the outdoors, and then it'll cluster pictures of possibly like flowers together, or rocks or something like that. For reinforcement learning, this is where we're really going to talk about DeepRacer here, and it learns from consequences of the actions in its environment. And when we talk about that, we have a slide here that really explains it into very plain English. So reinforcement in the real world, you reward positive behavior. So, you have your dog, it does something well, you give it a treat, you give it a reward. And that's where the reinforcement learning comes from. Your dog does something not so well, you don't reward it. And it teaches reinforcing good behaviors, negative behaviors, and then at the end of the result, you get a super dog. And that's what we all hope for. When we're talking about reinforcement learning, there's also some key terms we want to go over to help you on your journey. So when we speak about the agent, you can think of the agent as the software that acts to reach the specific goal. So in this case, it'll be the actual DeepRacer vehicle car or the virtual DeepRacer car. So, and what does it want to do? It wants to finish its laps around the track as fast as possible. The environment is going to be the racetrack, the surrounding of the racetrack, whatever the agent interacts with. In this case, we're going to be simulating it with AWS RoboMaker, and we're going to create a track for it. The agent starts off at the track. It'll try to get around the lap, or it's going to go off the track. Now, when we talk about the state of the current agent, it's essentially what the camera sees. So the agent has its state. It's either on the track, off the track, somewhere on the track, and that's the state. And the actions, this is where it's going to be taking, the left turn, speeding up, stopping, trying to get those reward functions. And then at the end, it's going to get those rewards, and it wants to maximize its rewards. And an episode is a complete cycle of this, whether the agent is the car on the track, or it goes off the track, or it finishes the track. And with that, I hand it off to my good colleague here, Mr. Todd Bevins.
Great. Thank you, Sehan. Yeah, it's like I said, I find this whole world very fascinating. And I wanted to take just a step back real quick and talk about the difference between AI, and machine learning, and what the differences that we're doing here. If anybody has a Roomba vacuum, you see the vacuum move around the room, and with its different bump sensors, it runs different pieces of its code. So if it bumps into something, it just knows to back up, and it moves on. It doesn't really learn anything. What's different with this is we're actually creating a model that will teach itself, in this case, this little car, to drive around a track, stay on the track, and try and get around the track as fast as it can. So we do that, and we incentivize these things using reward functions. And as Parth is going to show later, through our walkthrough demonstration of reward function, in this case, it's actually Python code. You don't actually have to understand Python code, because there's built-in examples inside of the DeepRacer console that you can access. But that is certainly one of the levers that we're going to pull to create a machine learning model that'll make you a winner. So let's go to the next slide. Next slide. Can we go to the next slide? Yep, there we go. So this is a good example of how this is going to work. In this example, we've got a straight track. In the real world, when we're doing this, you'll see we have all kinds of different tracks to choose from. But this example, very simplified. So you've got a straight track, and you can see the quickest way to the finish line, the green start square, to the checkered finish line, is going to be straight ahead and marked in orange. So go to the next slide. So what we can do is we can, using a reward function, we can incentivize our model to take the quickest path. And in this case, obviously, as we said, it's the orange squares and staying in the middle of the track. If it deviates from that, we give it a little less reward function. If it leaves the track, we give it no reward function. So through trial and error, our model is going to learn what yields it the highest reward function. All right, next slide. And in this animation, this is showing how the reward function is incentivizing our model to do what we want it to do. We want it to get it across the finish line as fast as we can, and the best way is the center line of the track. So this is done through what we call exploration and exploitation. And there are specific settings within our model which we can affect this. But as you watch, as you create your first machine learning model, you will see a representation exactly what we see here on the screen, where in exploration, I think if you move forward, it'll start the animation here. We'll see the car through, and it's going to be exactly like this. You have to understand your model is like a child. It doesn't know anything. It's like setting a toddler down and seeing what it'll do. And through its exploration, it's going to learn what to do. And through the guardrails that you set up inside of your machine learning model will help guide it to what behavior we want it to show us. In the exploitation, once it builds up a series of these explorations, it's going to say, well, that was a good outcome, so I'm going to apply that to my policy of being one of the good things to do in these situations. And then it does an exploitation. So then it's going to exploit or use what it learned next. And it's going to go through this process through its training. Let's go to the next slide. Okay, so this is the loop, how it learns. It's going to take an action. Based on that action, it's going to determine if the reward was positive. If it was positive, it's going to log that as something that it's going to want to keep, and it'll continue doing that throughout its iterations. So it's a constant action, reward, what the state is, and what the outcome was, and it'll apply the good things. At least we hope. And there'll definitely be some examples where a model can learn some bad behaviors and not perform particularly well. And the next one. Okay. So the input. Let's talk about the car here real quick. As I mentioned before, it's got a little camera. I've got one of them here. This one's slightly modified, but this is the camera that it uses. It's a 1080p camera, but in DeepRacer, we downscale that. It's 120 by 160. So it's a much lower resolution, and it also grayscales it. It takes away the color so that it's just a grayscale picture. So the camera takes about 15 pictures per second. And each of those pictures are a state. Now, trying to refer back to the environment that it sees. So once it takes these 15 pictures per second, it breaks apart these pictures into further pieces of what it sees in its environment. And what we can see there, we can see the center line, we can see the white lines that border the track, we can see the barrier in the background, we can see the green field. So all of these things is taking notes of where it's at in its environment, and based on that, it's going to be collecting the appropriate amount of reward or the lack of reward. Once it goes through a series of these iterations, and I'll show you later or Parth will show you later in the when you're walking through and creating the model, is as a hyperparameter that you can set is how many times it goes through these iterations before it decides it's a good thing and it's going to place it in its policy. All right, next. So here is a screenshot of the actual action space. And this is something you will see in the DeepRacer console as you're creating your model. The action space is what if you picture on the right-hand side, you see some arrows pointing up. This represents where the car is sitting and that it can turn 30 degrees to the left or it can turn 30 degrees to the right, and also the amount of speed that it's allowed. This is what we call a discrete action space, where we can further create guardrails around the car as to what options it has. If it turns 30 degrees to the left, what's the maximum speed we would allow it to go if it chose to do that? So we're not telling it what to do necessarily, but we're saying if you decide to do this, this would be a guardrail that you would impose to help the car along. In a way, it's kind of limiting the options of the car to expedite training. And next slide. So optimizing this, we use the OpenVINO. This is some software that's installed on this. As we mentioned before, this compute module, which is purpose-made for the DeepRacer, is an Atom processor. It's got 4 gigs of RAM. It runs Ubuntu, but it also runs a robot operating system, and it runs this software OpenVINO. And through the OpenVINO, it's able to take your model and apply it better to the control of the car. On the bottom there, you'll have these little GPIOs, which the servos directly connect to. There's a electronic speed controller. There's a servo that plugs into here as well. And there's one other wire too to let the car know when it has a battery and if the battery's low. But this component, this OpenVINO, helps optimize your model. And your next slide. So this diagram just kind of illustrates how it passes through this. You can see where the camera takes an image, takes a video. The inference engine processes that and passes it to control for the car. Let's take the next screen. Okay, and I think here, Parth, you're going to take over here for the, we're going to do the training in the AWS, or go to the next slide. Is this, this one more slide here. If you're wondering, what Seha was alluding to, where we talked about the different stacks, and really, if you were just handed TensorFlow and you were asked to create a machine learning model, this would be a fairly complicated task for you to set up. Even as you go up that stack, you've got SageMaker, which takes a lot of the workload out of that and things you can do inside of SageMaker. There's even no code tools inside of SageMaker where you don't even have to know how to code to create machine learning. And then we go above that, there's the other services that AWS offers that really simplify things. And DeepRacer is one of those. And DeepRacer really isn't a service itself. It's really it's a bundler of services. And if you look at this slide here, where we have these various AWS services, we have in the middle, you see there's S3, you see SageMaker, you see RoboMaker, you see Kinesis, Amazon CloudWatch. all of these services kind of work in concert to be able to do what you're going to do in the DeepRacer console. And if you were to set even those up all manually, it would be a very involved process. But DeepRacer makes it very easy to create a machine learning model by doing this for you. When you look at these, if you're familiar with containerized, computing, that's essentially what's happening. When you go into your DeepRacer console and you tell it to build a model, it's going to spin up these containers for you. So you've got a container running SageMaker and RoboMaker, and you have an S3 bucket. All of this stuff just for you to process your model. I wanted to make a note too that we're going to talk about this in terms of training it in a virtual environment. And that's where RoboMaker comes into play, where RoboMaker really is the virtual track and the virtual car that's modeled exactly to the actual tracks that we have and these actual cars that we have. And we train within this virtual environment. And only the training takes place in the virtual environment. When we actually do a physical race, we download that machine learning model. We're able to put it on the car, but the car doesn't learn anymore. All it does is going to apply what it learned inside of the virtual environment to the physical car on the physical track. In this slide here, this talks about the reward function. And the reward function, as I mentioned before, is Python code. But what's nice is they've created 3 different reward functions for you to choose from if you don't want to modify it. There are many more variables that you can modify this code for a reward function. I've seen some reward functions in excess of 300 lines of code. You can make them very complex, or you can make them very simple. Is one better than the other? It's your secret sauce. I mean, in creating your best model, you may be 300 lines of code in, and that works great for you. But I will say that even these simple example models that are included in the DeepRacer console can make winning models that are very fast around the track. This is the track component where this is what the inside of the virtual environment, what it sees. As I mentioned before, you see the track center line, you see the edges of the track, you see the green field, there's the blue barrier that goes around, and this is mimicking exactly what it's going to see in the physical environment. And as I mentioned before, what the camera's doing, taking those 15 pictures per second and then breaking it down into these little pieces and parts and figuring out where the car is at that 1/15 of a second and what decision it needs to make to get it the best reward function. This is a list of the reward parameters that you can choose. You'll see some of these used in the example reward function, but certainly not all of them. And these are tightly held secrets. As I mentioned before, there's an entire league that runs all year round. It's worldwide, and the competition is very stiff. And these top performers, they covet and they hide, their particular reward functions and their settings. That, as I mentioned before, that is their secret sauce. This is an example of one of those. This is the coordinate system. You can set up waypoints. This is one of the options you can choose inside of your reward function, where each track has mapped out waypoints, and you can specify those inside of your reward function. Much as the way I talked about the discrete action space, where we can limit the car or give the car what its parameters are for a number of degrees of turn, how fast it can go. The same way with the reward function, you can program in some of these guardrails into your reward function for your model. Next slide. And this just shows an example of that using the heading parameter in the reward function. Now, in terms of racing, what we determine on track and off track is the car can as long as it has one wheel still on the track, and that means the white line, as long as it's still one wheel is still on the white line, we consider that on the track. When it goes off the track, it's a reset, which means the car gets put back on the track. And depending on how we set up the particular race, there may be a penalty exercised into that. Because in the physical race, if you've ever watched the DeepRacer physical races, there's a person who's running around chasing the car, and in that role, they're snatching the car up when it drives off the track and putting it back on the track. When you see in the virtual environment, the virtual races where we are exacting a penalty, it's mimicking that same function of that person running and grabbing your car and putting it back on the track. And the next slide.
This is the other parameter, distance from the center.
Oh, yes. So, and when we're talking about, when we're talking about the reward function, there's the three canned ones. There's one that's follow the center line, and there's one that just says stay between the white lines. Those are the two of the three that are listed that way. And I think the third one is to avoid zigzagging. So that's a third one. This distance from center line is something that you can use where you're incentivizing the car to stay closer to the center line. So based on that distance from the center line, would give it a different reward value. All right, I'm going to hand off to my friend Parth here, and he is going to walk through building a machine learning model.
Perfect. Thank you, Todd. Let me know if you can hear me. Awesome. So I'm going to share the screen real quick. All right. Can you see my screen? Can you confirm?
No.
Not yet?
I thought I said.
All right. I think you should be able to see my screen now.
Yep.
Okay, perfect. Awesome. So I have an AWS console here. So there are a couple of ways to get started with this hands-on session. I would be performing the hands-on session on my screen right here. But if you do not like to listen to me and do the hands-on session, I would give you this link, which is a workshop link, which you can follow along so that you can do it in your own AWS environment. I'll be pasting that in the chat right here. And this is exact steps that I would be performing. What we would be doing is we would be going into an AWS console. We would be going to AWS DeepRacer, and we would be training our first model based on all of the learnings that Seha and Todd taught us in this quick crash course for us. Essentially, we are going to go through one particular process of training the DeepRacer model with an existing pre-canned reward function. So for that, I'm going to go to the search bar right here. Once it finishes loading up, I'll search for DeepRacer. Like Seha mentioned in the chat, we are giving away $35 AWS credits to help you get your model trained. So there is a link right there to get the access to the AWS credits.
And Parth, I just want to make sure everybody can see your screen because I cannot.
Oh.
I can.
I just want to make sure. I may not be unique. There may be others that are not seeing the screen. Can everyone give a thumbs up if you see the screen? This may be a me problem.
Perfect. Looks like folks can see the screen. And there is a presenter view tab, there is a camera tab, and there is a screen tab on the top. So you might want to select that to get access to the screen for the folks who cannot see it. So what I've done is I've clicked into the DeepRacer console. When you go to the DeepRacer console, this is the screen that you would be greeted with. This is one-stop shop solution for everything DeepRacer. You can come in here to take a crash course on reinforcement learning should you want to look at all of the aspects again. You can come in here and do community races. You can come in here and do virtual circuits. Your racer profile is here and all of that. So first portion is the racer profile. When you log into your AWS account, your racer profile would have a random name and a random avatar. First thing I would recommend you come in and do is go to this racer details section, edit details, and then customize your racer name. It has to be unique, and then customize your profile image here. After you do that, we would go into training your AWS DeepRacer model, right? So we have a getting started here. What you can do is you can go straight up to this create a model step 2 right here. So click on create a model, and when you go to create a model, click on this orange button that is called as create model. When you go into create a model, there are certain aspects that you need to fill out. And when you fill that out, remember the architecture that Todd mentioned, that the SageMaker was doing the training, RoboMaker was hosting the virtual environment, and all of the logs were funneling into CloudWatch and whatnot. Once you fill this particular wizard out, it would spin up that environment for you on demand. And when you say stop, it would take it down as well. That is the main value proposition of cloud as well. It is pay as you go on basis. So if you say you wanted to run this model for 4 hours, it would spin that environment up and it would run that environment for 4 hours. And at the end of the 4 hours, you would be like, oh, I don't want to continue anymore. It would just turn it down and you won't pay for it again. So I would give my model name as Snowflake Workshop First Model. Correct. That is going to be my first name, model name. I can provide the training job description. This first model I'm going to train on is going to be on the centerline model, centerline reward function. So I will just quickly take a note of this. Centerline hyphen reward hyphen function. Now, what we're going to do is we're going to select reInvent 2018 track. You would see a lot of different tracks here. So I'm gonna scroll down, and I'm gonna search for 2018 track. When you search for 2018 track, you would come and take a look at this. This is the 2018 track which was introduced in reInvent 2018. And this is the classic track that we run off of. This is inspired by Monza's track in Italy, which is called as Fortress of Speed. And we only saw fit. Looks like my screen sharing was stopped for some reason. Okay, yeah. So we only saw fit that we would use this since it is the fastest track available in the world out there. So reInvent 2018, we'll select that, and we'll hit next here. Now we're going to do time trials. There are different types of races depending on different sensors. If you have a LiDAR sensor on the car, you can do object avoidance. If you have two cars, you can do head-to-head racing. Since we are going to just get started, we are going to select time trial here. Time trial is where your car would train on um, the track itself, and then it would try to get the best time possible on that particular track, so that you're competing against time. Your time is competing against other folks' time. Now, there are different algorithms that you can select here. There is a PPO algorithm and SAC algorithm. Since this is an introductory session, we are not going to change any of it. We'll just leave it PPO. There are a bunch of hyperparameters here as well. You are more than welcome to read up on that and tweak with these things, but it is set to the best of the capabilities just yet, and it is going to be it is an introductory session, so we're not going to tweak any of it. um, I'll point you to the DeepRacer docs in case you want to read up and tweak that parameters. So I'll leave it time trial, I'll keep it PPO and everything as is, and hit next. Now remember, like we defined, that there are a bunch of sensors on the car, and the car is driven by the control board PCB, which has Intel Atom processor. Now, if you would think about it, you'd be like, oh, if I take a computer, single board computer, and if I put in a couple of sensors, it becomes DeepRacer. No, it doesn't. You would have to make it a robot in order to, in order for it to do those tasks for you, right? And a robot does a particular task which is defined in its action space. So this is where our DeepRacer robot needs to have its actions defined that you would allow those actions to be performed, right? So this is where we would define those actions. We would say that, hey, our DeepRacer car can move its wheels 30 degrees to the right and 30 degrees to the left. If I don't want that, if I do not want that broad spectrum, I can reduce it down to 20, 25 degrees as well. So I can do my left steering angle would be max is 0 and 25, and then right is 0 and 30. So I can tweak those actions here. For the sake of this session, I'm going to leave it 30 degrees on either side since I want to give it maximum dynamic range. Same thing with speed. On speed, you can do zero point 0.1 through 4 meter per second, and those are actually incredibly fast when you see a small device like this going on around the track. I like to do 1 and 4 here so that I'm covering the whole broad spectrum. That's my way of setting up speed and steering angle. You're more than welcome to go in and change these parameters and try out multiple models to get the billing model. So I'll just leave it as is. Just to confirm, I'm doing all that in continuous action space and not on the discrete one. Discrete is a little bit more advanced. I'll show you a quick look here as well in case you want to switch on to discrete. Discrete is where you would tell that my maximum steering angle is 30 on either side, and then my granularity is going to be 5. So it would divide 30 into 5, and it would put down those right here. And then same thing with speed. If I say my maximum speed is going to be 4 and divide it between 3, then it would have 3 different variants of 4, which is 1.33 meter per second, 2.67 meter per second, and 4 meter per second. And then when you multiply it with the options that you had on the granularity here, you would come up with 7 times 3, that is 21 different actions in your action space. So your car can take this much amount of turn and speed, this much amount of turn and speed, this much amount of turn and speed, and so on all of these different polar graph vectors. And you can go to advanced, and if you do not like something, you can tweak that saying, oh, I do not want this action. I want this action. I do not want this action. I want actually to perform it like this, right? So then you can pick and choose. You can do a lot of advanced configuration on your action list, and this is how pros do it. They define an action space, and if those actions are picked by the model in the training process, which at a certain point they do not want, then they replace that action with a different action and start from scratch. If they like the action space, they lock down the model, and then they go in and do different models. So for the sake of this workshop, I'm just gonna go with continuous action space like this, which is 30, negative 30, 1, and 4 meter per second. And I'm gonna hit next. Now this is where you can select the custom shell of your vehicle. And this is just how the cosmetic shell would look like when it is in training. If you train your model and send it to monthly qualifiers which are hosted on this AWS console, then you win different cosmetic upgrades like this. We're not going to do it. We're just going to select original DeepRacer just yet, since everyone has access to original DeepRacer. We'll select that and we'll go ahead and hit next. This is where the main nitty gritty comes in. Like, you have defined all the cosmetic things, you have defined some of the things which impact a lot of different aspects of the training. But if you do not define your reward function, your model would not know how to perform and how to reward itself. So this is where you would define a reward function. Basically, what this reward function is doing is, after each action that it takes, it needs to reward itself. Now, think of this. If you have a dog, like Sia mentioned, you had a dog, and anytime a dog performs a good action, you need to provide a treat. Now, imagine this same type of loop happening every 30th of a second. Every 30th of a second, a camera takes an image, and then it takes an action, and then it asks you to give a reward. It is definitely not humanly possible for you to provide a reward to that car to facilitate the learning every 30th of a second or every 15th of a second, depending on whatever the frequency is. So for that, computers are way faster than us, and that's why we define reward function. So every time it takes a picture, it takes a random action and says, "How did I do? Did I did I do good?" So this reward function would assess all these parameters and say, "Hey, you did really well because you stick closer to the center line," right? So check this out. On This is the code. What it does is, let's say the car was at the left turn and it took an action which is moving the wheels 30 degrees to the right, and speed was 4 meters per second. We are most certain that if it takes that action, it is definitely going to go out of the bounds because it is taking right turn on a left turn on the track, right? So it it has taken right turn, and so after that it would assess this reward function. So it would say track width was whatever track width came out, distance from center was maybe 5. So then it would go in and it would calculate different markers on where how far the car would be. And if the closest marker from is if the car is closer to the distance center line, then it would get the maximum reward. If it is a little bit farther, then it would get half of the reward. If it is very much farther, then it would get 1/10 of the reward. But in our case, remember our car was taking right turn on a left turn. So the car is too far, and that's why it would be likely crashed. And we're going to give a teeny tiny reward so that it understands that, hey, I should not be doing that again. But same scenario, imagine that it takes the wheels 30 degrees to the right and it executes that right turn properly. In that case, it would be closer to the center line, potentially, and it would get one reward. So next time it would remember that, oh, next time it would remember that this is the left turn. I took the action which had wheels 30 degrees to the left, and I got the best reward. So anytime you would go in and do the same action again, it would pick that action over any other action, and that's how the car would learn how to drive. So whatever you define in this reward function right here programmatically would define how your car behaves on the track. And if your car behaves on the track to your strategy, then that's how you win. So we define the reward function and we say, okay, my stop condition is going to be 60 minutes. So I'm going to train it for 1 hour. Now, in machine learning scenario, you need to provide more time so that it can unpack what all it has seen and what all is defined. The rule of thumb is more actions you provide in your action space, more time you should provide for that particular car to go through all the actions in a particular scenario. So roughly I like to do 240 minutes, but you can do 1 hour. Basically $35 credit that you are going to get is equivalent to 10 hours worth of training. So this is probably more than that. I would probably even do 2 hours to get started with something. So define your own reward function that you want to do, and then choose your time accordingly. And then you can take a look at different graphs to assess how you are doing as well. So if you're not doing great, then you can stop it and you can try again. Right? All right. So I'm going to go forward. I'm not going to automatically submit to the DeepRacer race. This is how you would get access to those cool, funky little cosmetic models, because more you would send, more you would qualify, and more you would get the cosmetic models. But I'm not going to do it for this workshop. I'm not going to claiming any prizes if I win. So I don't want an email to be notified. And I accept the terms and conditions, but I don't want to go into the leak, so I'm not going to accepting the terms and conditions as well. I'll just go ahead and create the model. And it says price notification email missing. That's fine. I'll just go ahead and continue. So what it's going to do after you finish up this process is it's going to spin up the infrastructure that I was talking to you earlier about. It's going to spin up that SageMaker environment. It's going to load up the reward function in there. It's going to open up the RoboMaker environment. It's going to put the action space in there, and it's going to tie them up together saying, okay, RoboMaker, you perform an action every 60th of a second. And then once you do that, send in the call to SageMaker to assess how it did. And then whatever learning it gets from that, it would put it down on Amazon S3 so that the model gets starting built up. And model is nothing but a dictionary. It has the information of what is the scenario, what action it took, and how much the reward is on that action. And then at any point of given time, once that model finishes building, you can download that model, put it on the actual car, and the actual car would take a picture. It would try to compare it with one picture that it sees in the directory, and then it would tie it to the um, action that it took during the training, and it would take that action depending on the highest reward. So machine learning is very simple. It's all statistics behind the hood, but it's just complex math that comes down to that. So that's why you feel that it is a bit different. This is Machine learning is nothing but statistics 101 with a lot of programming mixed in. I hope this was a great session for you to kind of get started with machine learning. I'm going to give you some resources to understand how the model works. But I have one model that I did earlier, right? So I'll show you the training graphs. This is how a model progression looks like. At every run, in every iteration, the model would tell you how much reward graph that it average graph that it received. What was the percentage completion time during that training? And after each training, it would evaluate how well it does on the entire track. So as a rule of thumb, if your green average rewards are increasing, you can identify that your strategy that you have keyed in is what the machine is learning on. So green goes up, your strategy is working. Your strategy is being implemented if green goes up. However, if blue goes up relatively, then you can say that your strategy is actually working towards the race, because then your model would be able to finish a run on the track itself for towards 100%. If I see here, then my maximum percentage of completion was 30, and so the car was only able to stay on the track 30% of the times. Other times it went out, and that's not good, because even though the car followed my strategy, that strategy was not correct. It did not give me close to 100% on average percentage completion uh, during training. Sorry, I meant red. Yeah, so it didn't give me that. So in this particular model, at this particular point of time, it gave me 64% of completion, and I would pick that as my best model and run it on the track. So this is how you would evaluate these graphs once you finish the training. So let's say this is our model that we finished our training. You can do several things. A couple of them is you can download the logs on training, and you can use Python to um, you can start taking that logs and putting that into Python and evaluate those logs, saying, oh, how did I do? Where can I change? What can I modify and whatnot? That's one thing you can do. Other things you can do is you can add more time to it. If you think that this time was not enough and you could, if given more time, it could have performed better, then what you can do is you can clone model. Clone is not copying a model. Basically, what you're doing is you're cloning the configuration of a model, and you're basically starting from that point with certain changes. So if you want to change your reward function, if you want to change your learning rate and all of these different things, you can do it. There are some things which are locked down, like an action space. So you might not be able to change that in case you need to add more time to it, but you do have some flexibility to provide during cloning of the model. So that's something you can do. And most important, when you're coming to the Snowflake Summit to raise this particular model of yours, what you need to do is you need to download the physical car model. It's a tar.gz file that gets downloaded like this. And that tar.gz file is what comprises of all the learning that you do here. I'll show you how to take the tar.gz file and upload it somewhere so that we would have access to that during the summit. But basically, you would need to do all of this right here and then go to this link, which is bit.ly brem timer. I'll put that link in the chat here as well as it would be in the recorded session. It is bit.ly/drem hyphen timer. Pasting that in chat here, right here. Now, what you need to do is you need to create an account here with your username as your racer name. So let's say if your user is Bruce Wayne and you do not want your real name as Bruce Wayne to be shown on the leaderboard, then you can use Batman as your username here so that your secret identity is never revealed, right? So put your username as your racer name. That's what is going to go on leaderboard. And we are giving prizes each day to winners, whoever tops the leaderboard, top 1 through 3. So put your username there, put your password, email ID, and create an account. And when you create an account, let me show you how it looks like when you log in. So when you log in with your username and password, I do have an operator view, but what you see is you would see model management right here. You won't see this operator section. You would only see model management. And that's where you would go in and upload that model that you just created, right? So this is the model that I'm going to select, and I'm uploading the model. And your model uploaded would show up in this list right here. This is where you need to be in order to race at the summit. If you're not there, then we would provide you some demo models for you to try out. But if you need to compete, you need to have a model, at least a model here. More models are really good. You can pick one per turn. So if you have more models, you can go as many times as you want, and will give you a chance to race your model and compete in the race. But you would definitely need models uploaded in DREM, that's DREM, in order to compete.
Or you
Now,
can see Sehan will be off on the side with a trench coat, and he'll be selling models to the highest bid. He'll be doing that as well. So.
yeah, jokes apart, yeah, you need the models in order to win. And yep. So this is the DeepRacer workshop that I showed you. This exact it shows all the exact steps that you need to go through in order to create a model. Exactly what I covered. So you should be able to look at this. And I'm sharing this particular repository. This repository is the DeepRacer experimentation repository by one of our training partners, that is Scott Pletcher from A Cloud Guru. They Scott went ahead and created some couple of reward functions on how to think about creating a reward function. So one is you take the track, you define the racing line like an F1 Pro user, and then you can think about it like this in this session. Or there are other types of self motivator, get fast, different types of reward functions. So you can take motivation from this, and you can train your reward function. I'm putting that link here in the chat as well. And last but not the least, we have the whole community, deepracing.io. So go to deepracing.io and it would have a Slack link to join in. And there are lots of people who have done a lot of deep racer events. They should be able to guide you on how to best train a particular model as well. So you're not alone. You have lots of resources and you have lots of tools. You just need to get working and get going on training your model. I think this is exactly what um, you need to get started. You just need to be creative and come up with your winning model. I would like to go to the presentation where I have defined a particular strategy which has an F1 type of scenario on how F1 racers think of taking a turn. And I would like to show you that reward function as well. So I'm going to stop my screen, and I'm going to ask Seya to um, share the presentation, which has the F1 example. The F1 example is really cool. It shows you how to think about uptaking one particular sector of a track and then approaching different things, right? So next slide, please. One more. Right, this one. So this is how you would think about waypoints, and this is how you would think about approaching a left turn. So we did during COVID times, we did virtual sessions quite a bit, and F1 racer Daniel Ricciardo, who is now part of Visa, Cash App, Red Bull team, they told us one of the cool key information where how to think about one particular sector and then take that left turn. So think of this scenario. This is reInvent 2018 track. If you need to take a look, take this left turn, which is identified in this green box, then what you need to essentially do is stay on the right side of the track between the waypoints 4 through 9, and then stay on the left side of the track between 10 through 20. So the code exactly that would highlight that particular type of behavior on the track is given right there underneath. So what you would do is you would define a particular yellow patch 4 through 9, and then you would say if you are in the right side of the track between 4 through 9, then I'll give you maximum reward function. And then same thing on that other blue patch. If you are on the left side of the track, then we would give you maximum reward function or maximum reward in your reward function. So now over the period of time when car learns, it would stay on the right side of the track in the yellow sector and left side of the track in the purple sector. And that's how it would enact an F1 racer taking that racing line. So please claim your promo credits. I'll pass it over to Seha and Todd back so that they can close out the session. But this is what I wanted to cover. Thank you.
Yeah. So just want to, for completion's sake, this is the self-paced guide here. We dropped the link in the chat. This is also the link in the QR code for the recording in case you're viewing this later here. And we also have the promotional credit, $35 to claim. Take the survey, you get $35. Apply that to your DeepRacer account so you get started. We also have a virtual race set up for this, specifically for the Snowflake Data Cloud Summit. You can submit it to there. But with that, Todd, Parth, any closing remarks?
No, it's like I said, it's a pleasure. Like I said, this is our passion. We want to make it your passion as well. Any questions that you got? Do we have an email address, or I guess we could drop that in there? I'd be happy to offer mine up here if you have any questions.
Yep, we're all on LinkedIn, social media. Feel free to reach out. Hopefully, we all see you at Snowflake Data Cloud Summit. Bring your models. We'll all be there.
Yep, and do not forget to claim your credit code. That Seha has pinned in on the chat. That would also follow up with a quick survey. If you have liked the workshop, please give thumbs up, 5 stars rating to that. And if you think we can improve upon that, then your comments would be helpful.
Is it going to be an expensive hobby? It can be, no more than your other hobbies, but that's the great thing about these DeepRacer events. We take these all around to different places, summits. So the physical stuff is there. The virtual racing you could also do. It's very affordable. It's $350 an hour to evaluate and train with. And when you think about everything that goes into the back end, $350 an hour is a very small amount of time.
The cars are, like I said, they're not inexpensive. If you're buying it new off of the Amazon site, it's $400 for a car. I have 7 cars, but some of these I bought certainly secondhand. If you look out there, a lot of people have these cars and they don't know what to do with them, but they're a lot of fun. There's other things, and there's other. If you go out on the interweb there, you will find people that are hacking these cars and making modifications to it. I certainly do that myself. It's like I said, it's a lot of fun, and I encourage you to get involved in it.
All right, and it looks like we got a question here that just asks, are there any student programs or anything for students?
You get a credit email after the survey.
It should present you a credit code once you're done with this one. The one on the
There
screen.
are special promos for students. So if you are a student, go to DeepRacer Student League and you can get started for free. I put down the link in the chat there as well.
And it looks like we've got one more question here. Is there any way to use a gaming PC with a GPU to train models on the cheap?
There are some ways that folks have tried to do that. So essentially, DeepRacer works well with the DeepRacer simulator on AWS SageMaker environment, and then you can pair it up with your AWS DeepRacer car.
Awesome. Well, Todd, Seha, and Parth, it has been such a pleasure hearing from you over the past hour.
If you touched upon it too, but there's also a separate environment that you can investigate. Putting it here in the chat, DeepRacer for cloud. Many of the very competitive world competitors, world record holders, use DeepRacer for cloud. They either run it in the AWS environment or they run it on their own bare metal. But it's essentially their own training environment.
Yep.
It looks like these questions just won't stop, guys.
Augmented with Raspberry Pi? You certainly could add a Raspberry Pi to it. Like I said, you're already running an Atom processor, but certainly if you wanted to stack another compute module on it, I've seen compute sticks used in these before to do some other machine learning on the actual car itself. Again, this rabbit hole is deep. When you start digging into it and seeing what people are doing, it's pretty shocking. But yeah, it's you could add a Raspberry Pi and have a separate compute module on there. There's no reason why you couldn't have that.
Yeah, if you're having problems with the AWS code here, if you take the survey we just linked, once you hit submit, it will pop up code up here. And this will be a code you can apply to your AWS account. So please make sure you copy that code out and paste it somewhere so you can keep it. For the AWS survey for your credit code, it will not be in your email inbox. It will come directly as soon as you're done with the survey.
All right. Well, I'm not seeing any more questions. So any final remarks before we close things out, gentlemen?
No, we really hope to see everybody at the Snowflake Data Cloud Summit or any of our other summit. Remember, we'll be giving out prizes every day for our top 3 racers. So see you there.
And we really look forward to it. We'll all be there, Parth, myself, and Seha. And there'll be more AWS team members there as well.
Awesome. I love to hear it. Once again, Seha, Todd, and Parth, thank you all so much for joining us today. It's been a pleasure.
Thank you, everyone. Thank you, everyone.
So before we dismiss the audience, just a reminder that today's session was recorded. So we'll be sending you that link via email. But you can also find it living on the DevOps website. That's devops.com/webinars. I'll be contacting 2 of you to win a $50 Amazon gift card. So thank you so much for all of your chats and questions throughout this last hour. If you would fill out our survey that is in the handouts as well as somewhere in the chat, that will also make you eligible for that giveaway. I would like to thank AWS for sponsoring today's program. And to everyone here, thank you so much for attending. We're glad to have you with us, and we hope to see you at a future Techstrong learning experience. Have a great rest of your day, and you may now disconnect. Thanks again, guys.
Thanks, everybody.
Thanks, everyone.
Thank you.